back. Today we're going to talk about the distance formula and standard position. The first part is the distance formula, and the distance formula is based on something that you already know how to do. You've seen it before. Let's get a little bit of a refresher. It's very important that you write this formula down because it's one of those formulas that's kind of like, I know how to use it, but when we get those little x2s and squares and y2, y1, they get kind of confused. So write this down here. If you need to, pause it and write it down, and we'll talk about it in just a minute. All right, now you have that written down. x2 and x1. We're talking about the distance between two specific points. So the first set of parentheses has to do with just the x coordinates. And when we do this x2 minus x1, we're saying the distance between those x coordinates. When we talk about y2 minus y1, that's the distance between the y coordinates. And we square those values and take the square root of it to find the distance. Where does it come from? Well, you see I've rewritten the distance formula, but if we take it to the coordinate plane, we can kind of see how this works. If I, for example, just draw a triangle in here, all right, and I am going to draw it in this way. And with this triangle, trying to draw a straight line, it's a little tough. It's based on the Pythagorean theorem, a squared plus b squared equals c squared. Look at how this works. If I denote these points, this is 1, 1, and up here is going to be 1, 2, 3, 4, 5, 1, 2, 3, 4, so it's going to be 5, 4. And down here we're going to have 1, 2, 3, 4, 5, 1. And if we decide that we just want to use the Pythagorean theorem, because we have a right triangle that's lined up on these axes, we can say, well, what is the length of this side? It's 1, 2, 3, 4. So this side length is 4. The side length going up is 3. And so if I apply the Pythagorean theorem, I end up with a squared plus b squared equals c squared. Well, this is going to be c over here. So I have 3 squared plus 4 squared equals 5 squared, because this is 9, this is 16, and this is a 3, 4, 5 right triangle. So I know that using this information, c must be 5. Let's look at the coordinate form using the Pythagorean theorem. I like to do it like this. I say x1, y1, and this will be x2, y2. I do that because I'm finding the length of this hypotenuse. Okay, so that's the length of the hypotenuse. Here we found the length of it to be 5. So we already know that it's 5. And so we'll just check our answers. Well, if I use the distance formula, it's going to be x2, which is 5, minus x1, which is 1 squared, plus y2, which is 4, minus y1, which is 1 squared. Well, look at this. Look at what happened here. I'll write it in pink so you can see. This 5 minus 1 becomes 4 squared plus, and this becomes 3 squared. Well, look up here. 3 squared and 4 squared. It's not a coincidence, because this represents the distance between these 2 points from an x standpoint. So this distance here is really x2 minus x1, because that's x is the side to side. So if I have 5 minus 1, that gives me the distance in between. The same applies for this y coordinate up here. This is really y2 minus y1. Well, that 4 minus the 1 gives me that 3 space. So it's not really surprising that when I do the distance formula, I get the same thing. So it's going to be the square root of 16 plus 9 is equal to the square root of 25, which is equal to 5 for C. Notice they're the same because the distance formula is based on the Pythagorean theorem. So why does it matter? Why don't we just use the Pythagorean theorem? Not every triangle is a right triangle, and we don't always want to have to draw it, and we might not be able to count the boxes. So when I look at this point here and I want to say, let's find the distance between these 2 points, I'm going to label them x1, y1, and x2, y2. And the distance formula is still going to be the square root of x2 minus x1 squared plus y2 minus y1. I still write out the formula because I like to be exactly sure of what I'm looking at. So let's subtract x2 minus x1, square it, plus y2, which is 5, minus y1, which is 1, square it. Let's do a little bit of math here. Negative 1 minus 2 would be negative 3 squared plus, and this is going to be 4 squared. Well, when I square a negative number, it's really negative 3 times negative 3, which will give me positive 9. That's 16. And in this case, we happen to end up with the same answer of 5. Not always going to be that way, but it happens. Try this next example on your own. The next example is just a general example saying, what if the point was xy, somewhere in the coordinate plane? And we're going to use the origin as our reference point, remembering, of course, that the origin lies at 0, 0. My suggestion to you, label those points, x1, that's hard to see, x1, y1, and you can make this x2, y2. So try that one on your own. The second topic on today's slate is standard position. Why do we use standard position? We use standard position so that we know always where we start from. And here's where we always start from. We always start with the initial side along the positive x-axis. That's here. And this is always the start. It's always the start. Well, what does it look like? It looks like this. A standard position angle, we're talking about an angle here, so it's going to have 2 sides. The initial side is always going to be the positive x-axis. And if I draw the second line up this way, the angle is going to look something like this. And if I just label it A, B, C, angle ABC has an initial side that's the positive x-axis, and its terminal side is in quadrant 1. And if the terminal side is in quadrant 1, we would say, remember, this is theta. Theta is in quadrant 1 because all of that angle lies in quadrant 1 because that terminal side is in quadrant 1. All right? What if it was in quadrant 2? Let me draw the next one in blue so you can see. In this case, we're going to say theta is this bigger angle, still the same initial side. That initial side is still the positive x-axis. But now theta is in blue, so we're going to say theta is in quadrant 2 because that's where the terminal side is. And so it's going to go around counterclockwise and keep opening up for standard position. Angles. If the terminal side of an angle lies on an axis, y or x, positive or negative, then it's called a quadrant angle. So, remember, this is always initial side, and so the positive y-axis is going to be 90 degrees because it opens up 90 degrees. The negative x-axis is going to be 180 degrees, and this one down here is going to be 270, and this is going to be both 0 and 360. Because the thing about this is they just keep going around. So if I go around all the way, that's 360. Go around again at 720, kind of like a snowboarder. what happens if an angle is 90 degrees? And then I have another angle that goes all the way around and lands on that same spot. Well, that's called a coterminal angle. And so what you need to understand is if they have the same terminal side, so for example 90 degrees, and then if I go all the way around, so I go 90 degrees, that's going to be 1. And then if I go all the way around, so it's 90 degrees, and then I go 360 around, those are coterminal angles. So 90 degrees and 450 degrees are coterminal. It works that way with any angle. If I had a 45-degree angle and I went around 360 to 405, still would be coterminal. All right? That's basically how this works. That's standard position. It's putting an angle with the initial side on the positive x-axis. All right, guys, come to class tomorrow. We're going to talk about coterminal angles. We're going to talk about standard position. We'll talk about distance formula. We'll see you guys next time. Thanks for watching.